In today's lesson from Unit 2.1, we'll be looking at congruent figures, especially congruent triangles. Two geometric figures are said to be congruent if and only if they have exactly the same size and shape. So our first two triangles right here are the same size, same shape, so they are said to be congruent. And these two trapezoids are also congruent to each other. Same size, same shape. They don't have to be facing in the same direction, however. In the second group, we have two triangles that are definitely not congruent and two rectangles that are not congruent. And that's because they are not exactly the same size. In two congruent figures, all the parts of one figure are congruent to the corresponding parts of the other figure. In congruent polygons, this means that corresponding sides and corresponding angles are congruent. When you write a congruent statement for two polygons, you must always list the corresponding vertices in order. For example, look at the two triangles below, and then we'll write a congruent statement. So in the figure, notice the markings. It says that angle A is congruent to angle D, because of the single arc there. Angle B is congruent to angle E. Angle C is congruent to angle F. And again, the corresponding sides are also congruent. So a congruent statement for these two triangles might look like this. Triangle ABC congruent to triangle DEF. But that's just one way to state how these two triangles are congruent to each other. So can the congruent statement be written in any other way? Yes, it can. It can be written, for example, as triangle CAB congruent to triangle FDE. So when you go to write your congruent statement, you have to be absolutely sure that the corresponding parts are congruent to each other. Another way to write this, maybe start with angle B and say triangle BAC congruent to triangle EDF. Again, watch how you name the two triangles. The corresponding parts must be congruent. In other words, angle B corresponds to angle E, angle A corresponds to angle D, angle C corresponds to angle F. So if we want to list the corresponding angles, we can say that angle A is congruent to angle D, angle B is congruent to angle E, and angle C is congruent to angle F. If we list the pairs of corresponding sides, say that side AB, it's marked congruent to side DE, so they correspond. You can say that side BC is congruent to side EF, they correspond to each other. And then finally side AC or CA is congruent to side DF. In our next example, in the diagram, we have polygon GHIJ congruent to MLKN. So they're both quadrilateral, so we don't have to use a symbol for the shape, but we're asked to find the value of x and the value of y. So if I notice, right here, line segment KL has 2x minus 4, and I know from the congruent statement that line segment LK corresponds to line segment HI. So I can say that LK is congruent to HI. So since those two segments correspond to each other, they must be congruent. So if I find the length of line segment LK, which I've circled as 2x minus 4, we're going to set that equal to whatever the length of line segment HI is. And here's HI at 12 centimeters. So set 2x minus 4 equal to 12, and then solve for x. So take and add 4 to both sides. We get 2x is equal to 16. And then divide by 2, we get x is equal to 8. Now we're going to need that in order to solve for y, because I kind of looked ahead and I saw that my y was right in here with angle K. So again, angle K corresponds to angle I. Look at the names of those two figures. So remember, the corresponding parts of congruent polygons must be congruent. So we know that angle I is congruent to angle K. So that means they have to have the same measure. So we're going to set 68 equal to 6y plus x. Now remember, we just solved for x, found out that x is equal to 8, so plug that in there. Take and subtract 8 from both sides, and we get 60 is equal to 6y. And that gives us y equals 10. And we're finished. Right, the third angles theorem states that if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So if I just draw two triangles that appear to be congruent, and we're going to label those quickly, triangle ABC and triangle DEF. Now, let's say we're given information that says if angle A is congruent to angle D, so mark those two congruent. And let's say we know that angle A has a measure of 60 degrees. And let's say angle B is congruent to angle E. Mark those two congruent. And let's say we know that angle E is 80 degrees. Then we should be able to show that angle C is congruent to angle F. Now here's why. If angle A and angle D are congruent to each other, and we know that angle A is 60, then angle D has to be 60. If angle B is congruent to angle E, and angle E is 80, then angle B has to be 80. Now if you notice, in both triangles we have two angle measures given, so we can find the third, because we know that the three angles in a triangle have to add up to 180 degrees. So that leaves angle C at 40 degrees and angle F at 40 degrees. So the measure of angle C is equal to the measure of angle F, and they're both equal to 40 degrees. So again, the third angles theorem says if two angles of one triangle are congruent to two angles of another triangle, then the third angles must be congruent. Okay, we're going to end today's lesson with a proof. We're going to show or prove that these two triangles are congruent. So in there, we're given information, and it's also marked in the diagram, that line segment AD is congruent to line segment CB. And we know that line segment, or we're given that line segment DC is congruent to line segment BA. And remember, if we want to say that these two triangles are congruent at this point, we have to prove that all three pairs of corresponding sides are congruent. So we're given two pairs of corresponding sides congruent, and right now we're going to show that line segment AC is congruent to itself. And we recognize that as the reflexive property. Next, we're going to work with the angles. Notice I didn't put all the given information together. I put the sides together in step 1, and step 3, we're going to put the information about our congruent angles. So angle ACD is congruent to angle CAB, and angle CAD is congruent to angle ACB. And again, that's given. All right, remember, in trying to prove that the triangles are congruent, we've got to show that all corresponding angles are congruent and all corresponding sides are congruent. So we're left with trying to prove that angle D is congruent to angle B. And notice that angle D and angle B are the third angles in the two triangles. So they must be congruent by the third angle theorem. Okay, we've shown that every pair of corresponding sides are congruent, every pair of corresponding angles congruent. We get to make our final conclusion that triangle ACD is congruent to triangle CAB. And that's just by definition of congruent figures. What we're going to be talking about this week is whether or not there are any shortcuts that we can take in order to prove triangles congruent to each other. Alright, good luck on the CYU and the homework. As always, ask your teacher if you need some extra help.